All right, guys, if you would please find your textbooks. We're going to turn over to page, purple. Mine says 1, but your textbook, it's page 59. Okay, you should be turned over onto page 59. We're looking at exactly solving problems with ratios of fractions. Okay, and we're going to look at problem or activity 2.1, comparing ratios of fractions. All right, so the table shows the weights of 4 different adult birds and the weights of their eggs. So I've got a pigeon, chicken, swan, and a robin. All right, the first question, the first step is says compare the weights of the eggs. List the birds in order of the eggs from the bird, with the heaviest egg to the bird with the lightest egg. Well, I need to see, okay, mother's weight, well, egg weight. So this is the column that I'm looking at, and I want to label it from the heaviest to the lightest. Well, I see the heaviest egg. It looks like that is going to be my swan. So my swan at 11 ounces is going to be my heaviest. Then my next heaviest is my chicken at 2 ounces. Then I get into my pigeon and my robin. Well, I need to compare my 2 fractions, so I'm going to see what is my decimal, and I'm going to use my handy dandy calculator. Well, my pigeon, that is at 0.75. And then my robin, well, let's see what my robin is. My robin's at 0.1. And even if I did look at the tenths place, I will see that 0.75 is bigger than 0.1. So then I have my pigeon is next at 347 ounce. And then that leaves my robin for last at 1/10 of an ounce. Okay. Now I need to determine the ratio of egg weight to the mother's weight, okay, for each of my birds. So I'm going to put these in fractions. So I'm going to start off with our buddy, our pigeon here, okay. So I want the egg weight, which is 3/4, over my mother's weight of 10. Then I have my chicken, and it looks like my chicken, I'm going to give me some equal signs. The egg weight is 2/80. Then I have my swan. Okay, my swan, it looks like it is 11/352. And then I have one more left, my robin. And our eggs weight is 1/10 over 2 1/2. Okay, that is the simplest way to create a ratio. All right. And then number 3, compare the ratio of egg weight to the mother's weight. So list the birds in order from the greatest to the least. So I want to put these in order from greatest to least based off, what is it? Compare the ratios of egg weight to the mother's weight. All right. So what I'm going to do is I'm going to find the unit rate for each of these. Okay. So I have 3/4. Whoops, that's 34. 3 divided by 4 divided by 10. And it looks like I am at, I'm going to change colors here, 0.075. Okay, all I'm doing is using my calculator. My chicken, I'm at 2 divided by 80, which is 0.025. My robin, I'm at 1/10 divided by 2 1/2, which is the same thing as 2.5. And this is at 0.04. And then I have my swan, and this is 11 divided by 352, which is 0.03125. All right. So I want to know which one is the heaviest. Well, it looks like my pigeon, because if I look, I'm looking at the second number here. My pigeon is first. Then I go into, well, I've got 3, 2, and 4. It looks like my robin. Then my swan. And then last but not least, my chicken. Okay. Last but not least, my chicken. All right. But let's take it a little bit further. So if we're looking at activity 2.2, so that's getting our feet wet just a little bit here. Let's take a look here. Although the ostrich is the largest living bird, it is also the fastest runner. The table shows the distance that 4 birds ran and the amount of time it took each bird to run that distance. Okay, I've got 4 birds: ostrich, great roadrunner, quail, and pheasant. And I see the miles that were covered and the time. So each row in the table shows a rate. The rate of each bird in this situation is the distance covered per the amount of time. So it's the distance covered per the amount of time. So it tells me the distance will be over time. All right. And let's look at our person here. It says, remember, a rate is a ratio that compares 2 quantities that are measured in different units. Well, I have 2 different units. So I need to write a rate or a ratio, okay, for each of my 4 birds based off of their distance over their time. Well, my ostrich, he went 22 miles. And how long did it take him? It took him 1/2 an hour. Okay. My great road runner, he ran 300 yards. And he did this in 1/2 or half a minute. UTE. My quail, he ran 20 yards. And he did this in 2.5 seconds. And then my pheasant, he ran 200 yards. And he did this in 5/6 of a minute. Okay, not just 1 full minute, just a hair under a full minute. Okay. But listen, can we really compare all of these? Well, I don't think so, because I got all different types of measurements. So let's see. The rates you wrote in question 1 are each represented using different units of measure. In order to compare the speeds, let's determine the unit rate in miles per hour. So in miles per hour for each bird. Consider the numbers in units for the original rate to choose a strategy. Analyze each worked example. So we know this. We know that it takes the ostrich 22 miles for 1/2 of an hour. So let's look at our worked example. The rate of the ostrich is already measured in miles and hours. You can set up a proportion and scale the original rate up to 1 hour. So I have distance over time. So I still have my ratio that I wrote, 22 over 1/2 equals, we'll now have 44 over 1/2. It looks like I went from 22 times 2 and then 1/2 times 2 to 1 to equal 44 miles in 1 hour, or written as 44 miles per hour. Why was the scale factor of 2 used in this worked example? And the reason for this is to scale 1/2 to 1, you need to multiply by 2. Okay, because 1/2 is twice the amount of 1. All right. And then I'm going to say this. You will hear this a lot. What you do to bottom, you must, or not much, must do to top. Okay, if you multiply by 2, so just like we did, so to get from 1/2 to 1, I have to do times 2 because it's twice. What I do on bottom, I have to do the exact same thing on top to stay equal. All right, this middle sign right here means equal. That means this fraction has to equal this fraction. So if I'm multiplying by 2 to get to here, I have to multiply by 2 to get to here. All right. Okay, let's try it out here. Okay. So it also gives us a nice little conversion here. There are 1,760 yards in 1 mile. Okay, so you know the great road runner ran 300 yards in 1 minute. All right, so the rate the great road runner is written in yards per minute. you can use conversion rates to rewrite the rate in miles per hour. So I'm going to start with my original ratio, 300 yards for 1 minute. Okay, I want to get to know how many miles per hour. So it looks like they went ahead and they changed this from 1/2 to 1 hour. Okay, and then I need to change my yards to miles. All right, so we can do this all at once or we can break this down here. If you notice right here, when they cross out minute on top and minute on bottom, it is the same thing. If I have minute on top and minute on bottom, they cancel out, and so do the yards. Okay, yards on top and yards on bottom, they will both cancel each other out to where when I multiply all of my fractions straight across, I'm going to be left with miles on top and then hours on bottom. All right, so they're left with this. So it looks like they're left with 300 times 60 times 1, then 1/2 times 1 times 1,760. Okay, and 600 times 6 times 1 over 1760 is equivalent to 20.5 miles in 1 hour. So this is not equal, this is equivalent, which means they rounded. Okay, if you ever see that, that means that that answer is rounded to the nearest whatever. Okay, so number 3 is asking, why is this fractional representation, let me make sure. Yep. Do we do? Yes, we do. Okay. Why is this fractional representation of each conversion rate important? Okay, so why do you think doing this fractional representation for each conversion important? It is important when converting from one unit, to the next to stay equal. Okay, it is important when converting from one unit to the next to stay equal. All right. All right, so number 4, it is asking us to determine the quail and the pheasant's speed in miles per hour. Let's do the quail together, and then I would like for you to pause your video so that way you guys can do the pheasant. Well, I'm going to switch back over here. Let me move my papers. Let's see. All right, well, my quail is 200 yards in 2.5 seconds. So I'm going to have this. I'm going to have 200 yards and then 2.5 seconds. Okay, well, I'm going to change my seconds to minutes. So it's going to say 60 seconds is equal to 1 minute. And then I need to change my minutes to hours. So 1 hour is equal to 60 minutes, meaning my seconds and my minutes are now gone. And then I'm going to copy this conversion here. Well, it's 1 mile for 1,600 and so many yards. So I'm going to have a 1 mile to 1,760 yards so that my yards cancel out. This all here reduces down to this. I'm going to have 200 over 2.5 times 60 over 1 times 60 over 1 times 1 over 1760. Okay. All right, so let's grab our handy dandy calculator. So I'm going to type in 200 times 60 times 60 times 1. And I reach 72123 zeros over 2.5 times 1 times 1 times 1760. And I get 4,400. Okay, now to simplify this, I'm going to divide the two numbers, 720,000 divided by 4,400. And I'm going to, let's see, can I make this into a fraction? Nope, let's just do the numbers. All right, let's round to the nearest, let's say 10th. So 163.6 miles for 1 hour. Okay. Now, can anybody tell me why do I multiply my numbers straight across? Well, that is the rule when you're multiplying fractions. When you multiply fractions, the way that you do this is you will multiply straight across. And since I'm multiplying all the way down, I just multiply all of my numbers from one end to the next. All right, let's look at my pheasant's speed here. Let's see. I feel like I messed something up here. 163.6. Did I do something? 200 over 2.5 is 8 yards per second. Let's see. Oh, I did that for 2 seconds. Okay. All right. And then let's look at the pheasant's speed here. I probably went way too far. All right. So pheasant's speed, I'm at 200 yards for, I'm trying to make sure I have the right numbers for you guys. Oh, I see what I did wrong. I didn't turn it into 1 second. Okay. I see what I did. All right. So I'm going to have the 200 yards. And it's going to be in 5/6 of a minute, which I'm going to go ahead and change this here for you to make it a little bit easier. And it's going to be 240 yards for 1 minute. Okay, let's make our life a little bit easier. Now let's change our minutes to hours. So for 1 hour, it's going to be 60 minutes. And we're going to move away our minutes. And then we're going to have 1 mile to have 1,760 yards. To take away our yards. And let's see what we get. So 240 times 60. I have 14400. And then 1 times 1 times 1760. I have 1760. So 14400 divided by 1760. And I receive roughly 8.2 miles per hour. Okay, I receive roughly 8.2 miles per hour. Let's go ahead and let me go ahead and fix this right here because I made a mistake. All right, let's go ahead and fix this quail. I'm going to do it over here. All right, so our quail is roughly going to be 8 yards per second. So I've got 200 over 2.5. And when I divide that down, I'm going to end up getting 80 yards per second. Okay, let me try this again. So 80 yards per 1 second. Let's change this into minutes. So I have 60 minutes, 60 minutes for 60 seconds for 1 minute. Right? Yeah. Yep. And then let's go ahead and do this. Let me do this math really quickly. Just give me just a second. So I got 4,800 over 1 minute. And then let's change the minutes to hours. So 60 minutes, 1 hour. And then we're going to have 1 over 1760. So 4,800 times 60 divided by 1760. I still get to the same thing. All right, so I just wanted to make sure. Okay, so now that we have this, wow, I don't know why I'm so off. I'm just trying to double check my answers. All right, write the birds in order from the fastest rate to the slowest rate. So I want to know the bird that is fastest to the bird that is the slowest. All right, so it looks like ostrich, great roadrunner, quail, and then pheasant. All right, so if I look back here, I've got 22 miles for 1/2 hour. Well, my ostrich, if I look back here, he was at 44 miles for 1 hour. My great roadrunner was 20 for 1 hour. My pheasant was 8 for 1 hour. And then my quail right here, it gives me 163.6 for 1 hour. Okay, so I believe I messed up on this one because our thing should be ostrich, my great roadrunner, then it should be my quail, And then it should be my pheasant, but my pheasant will always be last in this case. Okay, my pheasant will always be last. There's your answer. All right, if you guys have any questions, please let me know.